Welcome to our third tutorial about using parameters. In this tutorial, we're going to learn how to calculate the total surface area, volume, and mass of our block with user parameters that we define. I'm going to pick up right where I left off in my previous chapter. Open the Parameters dialog window, and let's begin by changing some names so they're more descriptive. Call this one wall, since this formula represents the distance of the wall, d0/16. Now let's look at d7. Let's rename it r1. It's the radius of our cylindrical entity. d10, that's the height of the base, 3/8 of an inch. Let's call it h1. Now when I mouse over the next parameter, d12, I see the callout consumed by work plane 1. This is basically the offset distance for work plane 1, or the height offset of the cylindrical entity. I'm going to call it hc, height of cylinder. d15 is the height of the cavity. I'm going to name it h2. Let me replace the equation as well. h1 minus wall. Let's delete the unit portion of the formula in direction 1 and direction 2. I'll leave variables 1 and 2 in their place. And we're ready to add our first new user parameter, volume. We'll click on the Add button. A new field appears below variable 2. Let's name the parameter vol1. To calculate the volume, we need to know the volume of the base minus the cavity, and then add the cylindrical segments. My units will be cubic inches. For the purposes of this tutorial, I'm going to calculate the volume in steps just so you can see what's going on. Let's start with the volume of the rectangular base. It's going to be L1 multiplied by W1 multiplied by H1. Click outside this cell to register. Now we need to calculate the volume of the cavity. Since we use the wall thickness, we don't have the length and width of the cavity. Let's create a variable that represents the length of the cavity. We'll call it L2, inches. OK. I need to subtract from the length of the base the wall multiplied by 2, since we've got 2 walls. The same goes for the width. Let's create a variable representing the cavity's width, W2, inches. OK. W1 minus the wall multiplied by 2. Now let's calculate the volume of the cavity. We're going to call it volume 2. It'll be in cubic inches. OK. And our formula, L2 multiplied by W2 multiplied by H2. Click outside the cell to register. Our next step, we need the total volume of the cylinders. We're going to call this parameter vol3. It'll be in cubic inches as well. OK. The volume of the cylinder equals the radius squared times pi times the height of the cylinder. Let's notate that here. R1 caret 2 capital P capital I. I missed the multiplication symbol between 2 and pi. Let me just slip that in there. OK, multiplied by the height of the cylinder, hc. Now to figure out the total volume of the cylindrical entities, we'll need to multiply this formula by variable 1 and variable 2. Let's click outside the cell to register. Now we're ready to calculate the total volume. Let's name this user parameter volume total. Again, the unit of measurement will be cubic inches. OK. Volume 1 minus volume 2 plus volume 3. Click outside the cell to register, and our volume displays in the nominal and model value columns. Now let's calculate the mass. We'll name this user parameter mass. Our unit specification will be pounds, lb. In order to calculate the mass, we need to multiply the total volume by the density of the material. The density of the plastic, let's use ABS plastic. Let me just plug in the density, 0.037 pounds per cubic inch. Click outside the cell to register. And here is our mass. Let's actually change the units in this instance to grams. What's really cool is that Inventor automatically recalculates all this for us. Our Lego block weighs about 3 grams. Let me make my parameter window just a little bigger to fit the additional user parameters that I'll be adding now to calculate the area. Okay, we'll add one more. Let's call it area. Unit specification, inches squared. We'll be calculating the surface area in a few different steps just to better illustrate what's going on. And in our equation column, let's enter a formula that'll give us the area of the base. To do so, we need to add up all the areas of all sides of the rectangle. Let's multiply the height by the length, and then we'll multiply that by 2, since we've got 2 walls of the same size. To that, we will add the height multiplied by the width times 2. Now let's calculate the area of the top and bottom faces. L1 multiplied by W1 multiplied by 2. Of course, we do have a cavity beneath the Lego block. And let me just take a normal view from the bottom, we'll be able to calculate the area. This area, let me just reposition a bit. We can calculate this area here. Let me rotate the block to show you the next area we will need to add. Here we can see the inside wall a bit. Now if we combine these two areas together, and then after we can use the wall area for the cavity. Let's click outside to register our results. I'll create a new user parameter. I'll call it area 2. Unit specification, square inches. Since we only need to calculate the vertical walls inside the cavity, our equation is going to be height 2 multiplied by length 2 plus height 2 multiplied by width 2. Oh, I missed the asterisk here. Let me insert that. Okay, and click outside the cell to register. Lastly, we're going to need to include the area of the cylindrical entities. Since we've already included the area of the top face of the base, we basically just need to use the side area of the cylinders. Let's add another user parameter. We're going to call it area 3. And it'll be in square inches as well. Click outside to register. Calculate the side area of the cylinder. We need to multiply the circumference by the height of the cylinder. The circumference of the cylinder is pi times the diameter. We'll enter a capital P, capital I, multiplied by R1, multiplied by 2, and multiply that by the height of the cylinder, HC. Click outside to register. Lastly, let's create another user parameter, area total. The specification of units, also square inches. And we'll start our formula with area 1 plus area 2 plus area 3. Click outside to register. And here is our total area shown in the nominal value column at 4.626 square inches. As a result of all this work, we've created a model controlled by 2 variables, variable 1 and 2, and 1 dimension, D0. From this, we were able to calculate the volume, mass, and total area of the part very easily. One more thing I wanted to show you. It has to do with the difference between the nominal value and the model value columns. In my window, they currently look virtually identical. Let's click Done. Now let's go to a dimension. We'll right-click on it, select Dimension Properties. Let's change the tolerance type to Symmetric. We'll enter an upper value of 0.01. Let's go to the Evaluated Size section. We'll use Upper. Click Apply and OK. Now let's rebuild our model. Update. Let's go to the Tools tab and activate the Distance tool. I want to check the length of this dimension now. As you see, it's 1.1 inches. That's the actual distance of this line. Let's go back to our Parameters window and go look at this parameter. Now we can see the difference between the two columns. The nominal column shows the value as 1 inch. The model value shows the actual distance on the model of 1.1 inches. Let's change the tolerance back to nominal, and let's go test our model. We'll enter 2 here for variable 1, and for variable 2, let's enter 5. And the values in our nominal and model value columns have changed. Oh my, I just found an error in my area formula. To get the total area of the cylinders, we need to use the number of cylinders, so let's multiply this formula by variables 1 and variable 2. I'm going to double check the rest of my formulas now. In area 2, we need to use 2 walls. And on the width as well. Click outside to register. And now we're ready to click Done. And go update our model now. And as you see, we've got. Let's change D0. Let's make it 1.5 inches, let's say, and click OK. And update our model again. All the relationships still look good. By the way, we've changed the tolerance back to nominal, so now the actual length should show as 1.5 inches. Let's measure it and check it out. There it is, and let's close this distance window. Now let's right-click, select Dimension Properties, and change the tolerance type to Default. Apply and OK. And this completes our 3rd chapter on parameters and concludes our section about using parameters to control your parts.